Hi, welcome to my video on deriving the sine law. And the sine law can be used to solve a triangle which is not a right triangle. We have a triangle ABC. So this is angle A, so this is small a across from it. This is angle B, so this is small b across from it. This is angle C, so small c across from it, so that large letters are the angles, the small letters are the sides. So the area of a triangle can be a half of BC sine angle A. So BC are the two sides and A is the included angle. Also, the area of a triangle can be a half of AC sine angle B. This is A and C with angle B is included. Also, the area of a triangle can be written as a half of AB sine C. So we have two sides which are A and B with the sine of the included angle C. And what we have is that all of these can be put together because the area of a triangle is, no matter which one of these we use, the area is the same. So each one of these are equal. So I'm writing down each one of them. Sine. So here's each one I'm written down because all the areas are the same. So what we're going to do now is divide each one of these by a half ABC. We're dividing each of the areas by the same expression. And that still makes it, we're dividing by equals. Since we do, the half cancels out, the B cancels out, C cancels out, so we get sine A over small a. And in this one we cancel, halves cancel, the A's cancel, C's cancel, so we get sine B over small b. Sine B over small b. In the third one, the halves cancel, the A's cancel, the B's cancel, so we get sine C of angle C over small c. So this is what we call the three proportions in the sine law. But any two ratios form a proportion. So in other words, we can have sine A over small a is equal to sine B over small b, or we could have sine B over small b is equal to sine C over small c, or we could have sine A over small a is sine C over small c. So any pair. So you can pick, as we said, A and B, B and C, A and C. All of these are true. So let's look at a triangle, which we'll label as A, B, C. So notice that we have, I just want to write this in now. Notice we have an angle A and a small a, angle B and a small b. Or we have angle B, small b, angle C, small c. So what happens if we have the sine of A over small a equals the sine of angle B over length B. So we have angle A, angle B, and we have the length of A and the length of B. So any three are needed. So any three of these, if we have angle A, angle B, so I'll just draw the diagram now and show you. So we have angle A and angle B, and small a, then we could solve the triangle because we have two angles and a side. We could also have angle A, angle B, and this B right here, not there. So we could have two angles on this side to work out the triangle. Or we could also have, B, A, and angle A. So any three of these will do to work out the sine law. So let's turn the page up and give ourselves more space. But I found, personally, that the shortcut that I use is this. To use the sine law, I say we need an angle and we need an opposite side of the angle are needed. So if I have an angle, and as I'm going to show you here, if I have angle A and I have side A, then the sine law will work. If I have angle B and side opposite B, so if I have angle B and side B, then the sine law will work. If I have angle C and small c, then the sine law will work. So we need an angle and a side opposite that angle for the sine law to work, along with one more of the angle or the sides. Which can you use to find the sine law? Well, let's see. The way I do it, again, I need an angle and an opposite side. So I have two sides and an angle. Do I have an angle? Yes. Do I have a side opposite? So yes, the sine law will work when we solve this triangle. Do I have an angle? Yes. Do I have a side opposite? No. Do I have an angle? No. Side opposite? Yes. Do I have a side? Yes. Do I have an angle opposite? No. So the sine law will not work when we have this situation. Side, angle, side. Notice now I have two angles here. If we have two angles, that means we have three angles. 180 adds up to a triangle. This is 140, so we mark this angle as 40. Now we have two angles. There's the third one of 40. So we have an angle and we have a side opposite. So yes, the sine law will work. Again, if you have an angle and a side across from it, you can work the sine law. Do we have any angles? No angles, no angles, no angles. So you can't use the sine law, no, because you don't have any angles. You have two angles. You can find the third one, which is added up as a 5, and we got 100, that's 111. So we need a 65. That makes 180 degrees. We have angles, but we have no sides, so the sine law cannot work. Again, repeat. To use the sine law, I need an angle and a side across from it. To use the sine law to find an angle or a side, we need an angle and we need a side opposite the angle are needed. Again, we need an angle and a side opposite the angle. We need an A and a small a. We need angle B and a small b. We need angle C and a small c. Note, the triangle is not a right triangle. All the ones we've been discussing here in this video, they are not right triangles. So to use the sine law, what do we need? We need an angle and an opposite side. That's the way I memorize it. I don't go, we need an SAS or SAS and all that stuff. I just say, do you have an angle and a side across from it? If you do, then you're going to work out your triangle. So if you like my video, click the like button, click the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.